It's no harm delaying a bit anyway. The traffic is, rain is terrible out there. I thought astronomers weren't suspicious, weren't superstitious. Sorry? Good evening. Welcome to the Recreational Astronomy Night meeting of the RASC Toronto Centre. This is one of two types of meetings that we hold. The other type is the Speakers Night meeting, where we invite an astronomer or researcher to come and report on their work. But tonight we're going to be hearing from members. And just before we start, I just wondered if we could see if there's anybody who's here for the first time tonight. A few people, welcome. So my name is Chris Vaughn. I'm just substituting for your usual host, Paul Markov, who's feeling under the weather tonight. And I'll just run through the agenda for the evening. So first up, I'm going to cover the sky this month. Then we're going to have a few more eclipse trip roundups from Jim Chung, Alan Kusugi, and Tony Horvatin. And then we're going to wrap up the evening with Arushi, Artash, and Vikas Nath talking about their Space Apps Challenge and visiting the Canadian Space Agency. So, and at the end, I think we're going to skip the announcements at the end tonight because we don't have Ralph with us, but we'll cover some of the events as we go anyway, so everybody will know what's coming. All right, so with that, we'll have the lights out. So this is the sky this month, covering the period from tonight to the next meeting on November 15th. Get my mouse working. Essentially, I'm going to cover a little bit about space exploration news and review a bit of this month in history, and then we'll get into observing and noting that for those who use the Observer's Handbook, that the time difference from the universal time listed in the Observer's Handbook will transition during this period with the end of daylight savings time. We'll come to talk about that in a minute. So I'm going to talk about what's up with the sun and the moon, where the planets are, what they're doing. We've got some comets to mention tonight, asteroids, some satellite phenomena, and we've got some occultations, both asteroidal and lunar occultations, to cover up tonight. And then I'll get into a few recommendations for some autumn targets. And I've already posted the contents of the information, contents of the presentation on the website at rascto.ca, so you can find it there. All right, so in case you're feeling drowsy and you want to doze off after the first couple of slides, I'll just give you the highlights to start off. So first of all, yay, hooray, we've got more than 10 hours of complete darkness setting in now. We have to pay for that with a bit of cold weather, but we'll manage. There's a new comet to look at, Comet Assassin. I'll cover that in a bit more. October 15th, we've got an occultation of Regulus by the moon. Then we've got morning zodiacal light, which we can keep an eye out for this month. Uranus hits opposition. We've got Orionids peaking during a dark moonless period, which is great. Then we've got a couple of asteroidal occultations visible right over the Toronto Centre. We've got another star occultation by the moon on November 5th, and then the other occultation, and then a little bonus is Venus and Jupiter sitting only 1/4 of a degree apart on November 13th. So I listed a bunch of the upcoming rocket launches and highlighted just one or two of them. So we have this, I always am intrigued by these classified launches by the U.S. Naval Reconnaissance Office, so we can imagine what they're sending up. We have cargo launches to the ISS here on the 12th, and most of these are broadcast online. You can watch. And then a couple of other really cool, interesting things. There's some more cargo launches. And then we have this, sometime in the 4th quarter, this Rocket Lab electron rocket from Mahia Peninsula in New Zealand. So they've started a rocket company down in New Zealand, and they're doing their 2nd orbital test flight from their facility on the North Island in New Zealand. So that's kind of a new player in the rocket business. And then somewhere in the next little while, keep your eye out for SpaceX's launch of their Falcon Heavy. That's 3 Falcon 9 rockets plus 27 Merlin engines. So that's quite the rocket when that goes up. Not too much on space missions this month. Of course, we lost Cassini recently, but Juno was still doing its thing around Jupiter in its 53-day science orbits. And this was a really interesting mosaic that was published recently from a JunoCam image series taken on September 1st. And it covers 95 minutes as the spacecraft swept from the Jupiter South Pole around to its North Pole through Perijove and then off. And I couldn't fit all the images in one slide, so we're going to do it in 3 sections. So this is the first section of the passes. Then we get into the more closer up to the planet. They're now calling this area this blue or indigo zone that they're keeping an eye on. That's quite fascinating. And then it starts, so sort of Jupiter starts reducing in size as the spacecraft starts pulling away. And there's a couple more frames as they go off to the North Pole. So if you want to see that in higher resolution, you can just go on the website and pick that up. Take a good look at it. So this month in history, just looking back, in 1758, we have the birthday of Heinrich Olbers, who was actually hunting for new planets in the area between Mars and Jupiter. And luckily enough, he found asteroid Pallas, the second asteroid discovered. And then a while later, he picked up number 4, Vesta. And then in 1632, we have the birthday of Christopher Wren, English architect and astronomer. 1877, we all know this name, Henry Norris Russell, American astronomer, co-developer with Hertzsprung of the famous Hertzsprung-Russell diagram showing the relationship between star temperature and luminosity. 1656, another well-known name in astronomy, Edmund Halley, English astronomer and mathematician, of course, he for whom the comet is named. And then in 1932, Ben Bova. And if you like science fiction and if you like science, he's one to read. He does a lot of hard sci-fi, especially around exploring the planets of the solar system. And 1934, Carl Sagan, American astronomer, planetary scientist, author, evangelist, maybe Martian, who knows? 1924, Audouin Dollfus, French astronomer and aeronaut, discovered Saturn's moon Janus while the rings were at a minimum, which would let these inner moons be visible near the planet. And then in 1709, Dirk Klinkenberg discovered the six-tailed comet, the Great Comet of 1744. And if you do a little research online, you can see a number of engravings and etchings showing sort of the way the comet appeared to people with its multiple tails. In astronomy history, back in 1884, Greenwich was established as the universal time standard. And then in 1997, of course, SNIF, Cassini, it was launched on October 5th, starting that terrific mission. In 1967, Venera 4 landed on Venus. The capsule was designed to float just in case they landed on liquids. They weren't sure what they were going to get. I even read somewhere that they had some parts of the mechanism that were made out of sugar so that they could dissolve and it could sort of transform into a different style of exploration. So that's something you could sort of look into if you're interested. And then in 1897, the Yerkes Observatory is founded there with its big refractor. In 1917, the Mount Wilson 100-inch telescope saw its first light. And then in 1957, we've got Sputnik 2 launched with Laika aboard, a little little tier, another tier for Laika. And then in 1967, we have Surveyor 6 launched, landing on the moon a few days later. And in 1967, the very first Saturn V rocket was launched, the uncrewed Apollo 4. In 1572, we have Tycho Brahe observing the supernova of 1572. And here's this diagram that he drew. This is, I think, Cassiopeia. It's in Cassiopeia. And this is the Nova Stella, the new star that he noted in his chart, item number I. Much later, we imaged it again. And here is a WISE infrared space telescope image of the area. And this is the supernova today in infrared. All right, moving on to observing. So a few of the star parties that we have coming up. So the RAC Toronto Centre Dark Sky Observing is going to be held this time at Glen Major Forest. We're going to give that a try. It's a bit closer, a bit more wide open sky, a bit more room in the parking lot for more people. So I hope those who may have not wanted to travel quite as far as Long Sault will give Glen Major a try. The window opens on next week on October 16th. First clear weeknight of the week. Then back in town on the week of the October 23rd, so the first clear evening of the week of October 23rd from Monday to Thursday, we're at Bayview Village Park.
Where's Glen Major?
Glen Major, the map to Glen Major is on the back of every issue of Scope, the back page. So it's in southern Uxbridge, North Pickering, kind of north of Ajax. Our solar observing session is coming up this weekend. Hopefully it'll be sunny for us, and if not, we have our backup date of October 21st. And then this talk covers the next interval, so the next scheduled solar observing session would be November 4th. And for that, we look to Sean here, who will give the no-go for that event. And for those who want to travel, the Jasper Dark Sky Festival is on, currently underway, or soon to be underway. And then there's a lot of other star parties on throughout the USA, if anybody wants to go a little farther away. Okay, citizen science. So the Globe at Night program is an event, is an exercise where regular people are asked to look at their night sky and gauge how bad light pollution might be for them. So essentially what you do during the reporting period is visually observe the magnitude of the stars that you can get to at your location. And the focus for October will be the constellation of Cygnus, and the focus for November will be Pegasus. And these are just an example of the charts they provide for you to sort of compare with what you see with what magnitudes you can reach visually. And if you can pick it out here, it gets a little busy by the end, but here's the summer triangle. So you've got your Deneb, Vega Altair, and Cygnus is sort of running down the middle of that, sort of Albireo kind of in the middle there. So there's Cygnus. And again, you can go to the website, you can look for historical information and more instructions on how to take part. Main thing to point out regarding the sun is that daylight savings time ends on November 5th. So as I said, your universal time minus 5 hours resumed for those using the Observer's Handbook. Astronomical twilight. So astronomers really like it when the sky is very, very dark. An astronomical twilight is defined as the point where the sun has set more than 18 degrees below the horizon. So under ideal conditions, you could almost not be able to distinguish between the sky and the ground. It would be that dark. And that's the period of time where we like to do our imaging of deep sky objects when we have very little sky glow. So astronomical twilight actually ends tonight at 8:15 p.m. and picks up again at 5:53 in the morning when the dawn begins to break soon after that. So that gives us about 9.5 hours of imaging time. But the good news is that a month from now, the amount of imaging time jumps over 11 hours, and that's about an increase of about 2.5 minutes a day. Apogee and perigee times for the moon, and here's what we want to know about is when the moon's in the sky. So these are the various phases coming up. So we have last quarter on the 12th, and then we have the all-important new moon on Thursday, October 19th, followed by the first quarter on the 27th, And then the next full moon, which is the frost moon or the beaver moon, happens in early November on the 4th. And just to mention that there is an International Observe the Moon Night event, which is coordinated events worldwide on October 28th. For those interested in seeing every last bit of detail or wring every last bit of goodness out of the moon that they want, you can take advantage of libration, which is the wobble of the moon due to the particulars of its orbit. And this information is in the Observer's Handbook every month if you want to go looking for it for yourself. But essentially, these are the times when you can see most of the eastern or western limbs, or most of the features at the top, northern limb or the bottom limb, by just looking at the angle that the moon is sort of tilted left, right, or up and down. And these are the dates when you can get those extra looks. See those extra features that are on the edges of your moon charts. Okay. Between the next new moon and about the period 2 weeks after the next, between the new moon and the next full moon, is the optimal time for looking at zodiacal light in the morning sky in the east. And the zodiacal light is the glow produced by interplanetary particles in the plane of the solar system that is scattering sunlight. And it's sort of, the sun is down here and it's illuminating all this material. And so just before dawn, for maybe half an hour, you can look for this wedge of light that sort of flanks the ecliptic, which is this line here, and look for this glow of the zodiacal light. Not to be mistaken for the Milky Way, which is further to the south here. So what's with the planets this next 4 weeks? Well, right now, as we know, we've got Venus and Mars in the pre-dawn sky. So this would be the pre-dawn sky. Jupiter is getting close to solar conjunction, so it's out of the picture for a little while before it rejoins the morning sky. I'll talk about that a bit more in a minute. Then in the early evening sky, we're going to get Mercury coming up in the next little bit. Saturn is now drifting into the sort of getting towards the evening twilight, so it's getting past its prime. And then kind of in the middle of the night, which is sort of the center of the diagram here, we've got Uranus and Neptune, which are more or less all-night targets. And I'll cover a few more details on that in a minute. So Mercury, what's Mercury doing? Well, it's for the month of November, it's going to basically give us a very poor evening apparition. So the problem with this is that the ecliptic is rather steep in the evening, and then Mercury is already also sitting below the ecliptic. So it's not going to rise very high in the sky at all. And in fact, it's going to sort of do a shuffle sideways for most of the month. But if you want to give it a try, that's where it will be. If you do get a telescope on it, you'll notice that its disk is growing in diameter and waning in phase as it goes. Venus, as I said, it's in the pre-dawn sky. It's been steadily dropping sunwards for quite some time. In a telescope, it shows nearly a full phase. As it's heading downwards over the next 3 or 4 weeks, it's going to pass a number of objects. So it'll pass Porrima, double star Porrima on the 22nd. Then it'll drop down and pass Spica on November 2nd and 3rd. And then, as I mentioned, very close to Jupiter on the 13th. I'll give you a diagram of that in a minute. Mars, in the meantime, is in the same neck of the woods. It's sort of climbing up, being carried upwards by the motion of the sky. And it's in the eastern pre-dawn sky, so its disk is slowly growing and slowly brightening. It's still quite some distance from us. On the 17th, we're looking for the old crescent moon to be sitting only about 1 degree to its left. And then when the moon does its cycle a month later, it comes back and passes it on the left again, but not as close. Okay, here's what I was talking about. So Jupiter is in the eastern pre-dawn sky after its conjunction on October 26th, and then it'll be moving prograde from Virgo into Libra on the 15th. But on the 13th, so Venus is descending, Jupiter is rising, and on that morning, they'll both be within 0.25 degrees of each other. So this is a 30 arc-minute circle. So you imagine if your telescope eyepiece sets up about a half a degree or about a full moon diameter field of view, then you'll get Venus and Jupiter and its moons at the same time. So that's interesting. But what's more is that both of these planets being very, very bright, they'd be a great thing to chase during the daytime later that day, to see if you can pick them out in the daytime. So that would be something to put on your calendar to try. Saturn, as I said, is in the sort of southwestern evening sky. It's we've still got some good views of it for us now, but it's certainly starting to show the signs of it leaving town. But right now it's in Ophiuchus, and it's setting about 9:50. But an hour from now, it'll be setting about 6:50 p.m. On the 23rd of October, we have the young crescent moon sitting about 7 degrees away. And of course, the next night, the moon will hop and sit sort of here. So you've got sort of 2 nights where you've got the pair in view. Uranus. So Uranus is magnitude 5.7, so it's certainly within view of binoculars in a dark sky and certainly a telescope. So it's going to reach opposition on October 19th. So that's the day of the year when we're closest to it. And it's slightly brighter and slightly larger than it is at any other day. It will be observable all night because it's rising as the sun sets on that date. And that sets us up to view it pretty much as an all-night object for the entire month. For aid in finding it, see if you can see this naked eye star Omicron Piscium, which is only just 2 degrees below Uranus. And it's not moving much at all, so it'll be sort of in the neighborhood of that star for quite some time yet. Neptune is dimmer, magnitude 7.85. It's in Aquarius until November 22nd, when then it reverses direction and starts prograde again. And it's basically observable as soon as it's fully dark until about a few hours after midnight, sort of maybe 3 o'clock a.m. Now, and then maybe 12:30 a.m. by the time of our next meeting. And it also has a little marker star you can use, this dimmer star, but it's Lambda Aquarii, or otherwise known as Hydor, and it's just a half a degree above Neptune. And then October 30th, watch for the moon to be sitting about 2 degrees from Neptune. It's not going to be a very good view with the bright moon next to the dim little planet, but they certainly are in the same area. Another one, minor planet asteroid Pallas, which I mentioned in the history section, is sitting at magnitude 8.2. Unfortunately, it's well below the ecliptic. Here's the ecliptic way up here in the southern sky, but it is moving southwest through Eridanus this month, and it reaches opposition on October 29th when it's 1.695 AUs from us. So it's something you might want to try for. I like looking at what's happening with minor planets. So the Minor Planets Center keeps tabs on everything that's discovered. And so between January 1st and today, another 1,338 near-Earth asteroids have been detected just this year. The near-Earth asteroids in this cartoon are the red dots. So here's Earth in its orbit, and these are all the red dots, which of course have been added to considerably at a rate of about 157 every month. The minor planets, which are the green ones, 20,435 extra ones or new ones this year alone at a rate of about 2,405 a month. And of course, much of that is done with robotic observatories, robotic telescope and camera systems. Another 39 new comets this year, including one I'm going to mention in a minute. And that's at a rate of about 5 a month. And that's based, all of this is based on about 13 million observations just since January 1st. So we're definitely wanting to keep tabs of all these objects in our sky. Okay, so here's the new comet I was talking about, Comet Assassin. And it was discovered in July of this year. And there's an image that was taken by Eric Brisnick in Belgium. And Assassin stands for the All-Sky Automated Survey for Supernovae. So I thought that was pretty cool. Right now it's a circumpolar comet, observable with large apertures and or dark skies, about magnitude 8. And the projections for its brightness curve are that it will brighten a little bit more, but maybe not a lot more. Just to give you an idea where it is, so here's Polaris, and here's the path of the comet over the next 4 weeks. And it's going to pass extremely close to Alpha Camelopardalis, this star here, on October 28th. So that might be an interesting little view. Meteor showers. So we have several meteor showers that are underway. The Orionids started on September 23rd. And this is a, if you ever go to the AMS Meteor webpage, during the active meteors, the periods of each meteor shower's active period, they generate these animated graphical displays that are in three-dimensionally rendered the solar system and the path of the debris train. So this is basically showing the orbits of all the inner planets, and you can see how the debris from the comet that has left the Orionid meteor shower debris is at an oblique angle to the plane of the solar system. And of course, and on an annual basis, then Earth will, here's Earth, will cross through the stream of debris and produce the meteor shower. So the Orionids are going to peak around the 21st of October at a peak rate of about 10 to 20 meteors per hour viewed at the zenith. These are pretty fast meteors. The debris was left by Comet Halley. The moon will be just past new at the peak, so that should make for good viewing. The Orionid meteor shower is the radiant for it. Of course, you can look anywhere in the sky for the meteors, but you can tell they're Orionids if they're traveling away from the radiant, which is sort of in the club of Orion, sort of sitting between the top of Orion and the feet of Gemini. So here's Orion. You can see his belt. There's his sword. There's the Orion Nebula. And here are the meteors sort of radiating away in this long exposure photograph. The northern Taurid shower is also underway. So this one will peak overnight around November 11 or 12 at a weak rate of only about 5 meteors per hour. These ones are medium speed meteors. They're left by a comet, periodic comet Encke, and they consist of larger grains which generally favor producing colorful fireballs. So they're few, but they are maybe more spectacular. And near the peak, the moon will be about 34% illuminated and rising after midnight, which is sort of prime meteor time. So you may want to do your meteor looking or meteor hunting in the evening around the peak period. And the radiant point for the northern Taurids is in Taurus, near the Pleiades. There's the Pleiades there, and you'll be able to see that they're radiating in a direction away from the Pleiades area. And the Leonids. The Leonids are going to start up early in November, and they won't peak overnight until after the next meeting, but there's no reason we can't keep an eye out for some. These are derived from Comet Tempel-Tuttle, and these ones are typically fast and bright, with many having persistent trains. The nice thing about this one is that the peak is going to happen when the moon is a new moon, which gives us a nice dark sky for meteor hunting. And the radiant for these is in the sickle of Leo, and that's sort of in the eastern sky, in eastern pre-dawn sky. For those looking for space station passes, right now we have a series of evening passes that last until the 18th, mostly between 7:15 and 9:15 p.m. And then there's a gap, and then a morning series commences on October 28th, with most of those between 4:30 and 6 a.m. There's a few fairly nice ones coming up over the next week or two. So I've listed them here, and they're also in the PDF that I've already posted to the website. For those that want to see iridium flares, then please look for iridium flares sooner than later, because they're starting to deorbit the satellites that are producing these flares and replace them with satellites that don't have flares. And so the iridium flares nowadays are happening mostly between about 6:45 and 8:30 p.m. and in the mornings from 7 a.m. to 7:45. So get your iridium flares while you can. If you want to know how to see them, you can go on to heavensabove.com and enter your location. And then you can also get smartphone and tablet apps. And I usually list them, or always list them, in my weekly Skylight email, or post them on Tumblr if you want to get what's up for this week. So occultations, we've got some cool stuff to talk about. So on October 25th at 5:30 in the morning, we have a rank 100, which means a very high confidence asteroidal occultation of this asteroid Ate, or I don't think it's 8, it must be Ate, occulting the star. And this is the predicted track that passes right through Kitchener. And then the 1 standard deviation uncertainty would be the blue lines here, which certainly encompasses Markham, Toronto, and the Hamilton. So the Golden Horseshoe area are all within a good sight of looking for that asteroidal occultation. And that's going to be a small dip, 0.65 magnitudes for 13 seconds, nice and high, 73 degrees above the horizon for the star. And then on November 11th at 8:30 in the evening, a very convenient, pleasant time, we have asteroid Messalina occulting another star. That's going to dip 3 magnitudes for 6 seconds at an altitude of 58 degrees. And again, here we have our track running through Lindsay and sort of Aurora area down through Guelph and Kitchener, and our confidence limits encompass our whole GTA area. So no reason not to go and check those out unless it's cloudy. So that's what we have to hope for. It's clear. In terms of lunar occultations, so on October 15th, we have an occultation of Regulus that happens in the morning, so that will ingress behind the leading lit edge of the moon about 5:47 in the morning, and then about an hour later, Regulus will reappear from the dark edge of the moon at about 6:34 a.m. If you're wanting to watch these events happen, unless you're very confident on where the star will emerge from the moon, then it's better not to use too high a power in your telescope so that you can encompass more of the moon's edge and then see the object reappear. Then there's a second one that happens on November 5th. In this case, it's the star Aldebaran. And this is just the screen track is just the moon's orbit. So it shows the moon is going to pass through the triangular face of Taurus, which is the Hyades cluster, and then eventually hit Aldebaran. For us, about 8:05 p.m. and then egressing. So it's nearly a full moon. It'll egress from the dark limb at about 9 p.m. So astronomers always want their clearest views of the objects they're looking at, and the best way to do that is to wait until they're the highest that they can be in the sky. And the objects that are rising and then traversing the sky and setting always reach their maximum height when they cross the meridian, which is due south. And so we like to know what's happening on the meridian sort of for planning our observing programs. But even more than that, you want to look through the least amount of air you can. So the best thing to do is to look nearly straight up, because the lower in the sky the object is, the more air blanket you're looking through. And this circle I've drawn here represents between 1 air mass, which is the sort of minimum, down to 1.5 times that. By the time you get down into here, you're getting 2 and 3 and 4 and 5 air masses. So it makes the objects twinkle more and extincts them, makes them somewhat dimmer again. So you want to focus on objects that are sort of very high near the zenith. So around 8 p.m. on October 20th, which is the next new moon area, new moon time, the objects that are sort of on the constellations on the meridian would be Capricornus, Aquila, Western Aquarius, Aquilius. Aquilius is the cute little one, little baby horse that sits beside Pegasus. Delphinus, Sagitta, Vulpecula, Cygnus, Cepheus, and Eastern Draco. And then 2 hours later at 10 p.m., we pick up Pisces Austrinus. Again, it's not optimal for mid-northern observers because it's so low in the sky, lots of air mass. But I mean, if that's your only time to see these objects, you make the best of it. So Pisces Austrinus, then we get into Aquarius, we get Western Pisces, Pegasus, Little Lacerta the lizard, and Cepheus. And then 2 hours later, we pick up Sculptor, again, really low in the south, Western Cetus, Pisces, Eastern Pegasus, and Andromeda, Cassiopeia, and Cepheus. And finally at 2 a.m., we pick up Fornax, a bit of Eridanus here, the rest of Cetus, and then we get into Aries, Triangulum, Andromeda, Perseus, Cassiopeia, and Camilla Pardalis. All right, so what should you look at these days? Well, it's a great time for observing because the bugs are gone, the air is cool, it gets dark nice and early, but maybe you're tired of the same old Messier objects. So why not try Caldwell's? So Caldwell's include many of the objects that you're already familiar with. And what are the Caldwell's? Well, we all know that Messier's catalog is around 109 objects that are visible from the deep sky catalog, viewed visible from Paris, where Messier did his work. Sir Patrick Moore of the UK thought that Messier missed a lot of good stuff, and so he decided to create another 109 targets that are not Messier's, that are sort of the best of the sky that Messier missed, but he decided to include the entire sky, northern and southern hemisphere. So if you set out to see all the Caldwell objects, 109 of them, you have to plan a trip to the southern hemisphere at some point to pick them up. And luckily enough, when I was in OSCI with Ian and Tony and Phil and the rest, I decided to start at 109 and work down. And I got about 40 of them done from the southern hemisphere. So I'm actually pretty good shape to pick them up. But I'll just cover a few things that you might pick up. So this is Stellarium. You can configure Stellarium to show you only certain classes of deep sky objects or certain catalogs. And this is showing just the Caldwell objects. So here we have the northeastern sky around the new moon at 10 p.m. And we've got a few things you can try for. So here's the cat's eye. Again, your mileage may vary depending on your telescope. The cat's eye's up here in Draco. Then we've got the fireworks galaxy down here at Caldwell 7. And again, this is going to rise through the night, so don't worry about it being so low at the moment. Then we have the ET cluster, or otherwise known as the owl cluster or the dragonfly cluster. It sits here in the, if you make a 90 degree in here with Cassiopeia, C13 sits right there. The double cluster has one of the Caldwells. It's Caldwell 14, so it's sitting right here. And then we've got the blinking planetary, which is Caldwell 15. It's sitting up here in Cygnus. And the North American nebula is Caldwell 20. It sits up here just below Deneb, Emission Nebula. Then you've got Caldwell 22, the blue snowball, another planetary nebula. And these objects are great using oxygen 3 filters or ultra high contrast filters to boost their light. This is cool. This is the Outer Limits galaxy. It's Caldwell 23. It sits here in the bottom end of Andromeda. And then we've got the Veil Nebula up at the bottom lower wing of Cygnus, Caldwell 33 and 34. And where did we miss one? Yeah, there we go. And a couple more. The Hyades itself is a Caldwell object. It's Caldwell 41, so it's the face of Taurus the Bull. And finally, we've got the mini Sombrero galaxy, which is Caldwell 43. It sits down here in the bottom part of, upper part of Pisces, in the bottom part of Pegasus. And the Propeller Galaxy, Caldwell 44. And this is one that inspired us to do some of our dark sky observing and our peculiar galaxy observing when we were in on the eclipse trip, which we'll talk about in a little bit. So that's Caldwell 44. It's there sitting right there in Pegasus. So those are some, hopefully those are some ideas of things you might not have looked at before. Whoops. And that's it, except for Comet Assassin and Comet Pan-STARRS by the Pleiades. Thanks. Any questions? No?
How far away are you going to be looking from the source?
Well, the Earth is plowing, the Earth is being carried into the debris field like it's like bugs on a windshield. So they're hitting the Earth's atmosphere as we hit the cloud and burning up in all directions. So we're traveling through the source. We're going to be enveloped by it. But really the only meteors we get are the ones on our prow of our boat or the windshield of our car as we head through them. So that's why that's why we recommend certain times and dates to look, because that's the point where we're really plowing straight into them the most. Yeah. That's it. All right, thanks. So up next is Jim. Oh, we have one more?
CBC's got a story. There's an asteroid passing at 50,000 kilometers of Earth tonight.
Yes. Yes. So after about 1:30, something in the morning, there's an asteroid. It's about the size of a house, 25 meters in diameter. It's going to pass, I think, within 0.13 lunar distances. So SLU will have a live feed where you can watch it happen. And it's not going to be clear here, so looks like it's going to be SLU. Yeah, so over the South Pacific. Great point. Thank you. All right, very good. So I'll call up Jim. Well, we need it for the broadcast. Circles around like that. Right on, and move it around 1 second.
That's great. Am I okay for sound? Oh, is this for sound? Okay. Welcome. So thanks for coming out tonight on such a rainy night. So it's the Great American Eclipse, Glendale, Wyoming, and related solar phenomena from Toronto. So now that I'm securely into my 5th decade of life, I've really come to appreciate the study of history. I think knowing the past helps you know the future. So 140 years ago, sorry, oh, not bringing forward. Oh, there we go. There was another American eclipse that occurred in the summer and also viewable from Wyoming, specifically Rawlins, Wyoming. And there's some stunning parallels between 1878 and today. For example, both eclipses could be seen from Wyoming. The US was just a decade removed from the Civil War, and today they're just a decade removed from the Great Recession of '08. The White House was at an all-time low. And the US president won the election by winning the Electoral College, but not the popular vote. And of course, we have this. There was a fairly low opinion of the US worldwide, and the opinion of the US is in decline today. And belief in science was low back then, it's still low today. Just to give you an example of how low the belief in science was back then. Sorry, trying to get this guy to move forward there. There we go. This was a bestseller printed in 1873. Sex and Education, A Fair Chance for Girls, written by Dr. Edward Clark, MD. And it was so popular, there was a second printing in 1884. So Dr. Clark contends that the proliferation of female colleges and co-education is harmful for the American women's health. He said that higher education taxes the brain and causes the atrophy of a girl's body, especially her reproductive organs. And I will quote this is not my words, his words. He said that higher education changes the character of a woman, eliminating all trace of maternal instinct and developing a personality of Amazonian coarseness and force. I'm very serious, this is what he wrote. Fortunately, history remembers the American expedition to this eclipse as one of serious science. And in fact, none other than Thomas Edison was a member. Now, for those of you who are too young to know who Thomas Edison was, he was the first celebrity inventor, and he was way bigger than Elon Musk is today. This is also the first modern eclipse, because instead of having to struggle for months to get to the path of totality, Edison enjoyed Victorian comfort by taking a train from his home in New Jersey all the way to Rawlins on the newly finished Union Pacific Railway. Now, one of the science goals for the expedition was to find the planet Vulcan. And to be clear, I'm not referring to the planet Vulcan orbiting 40 Eridani. That's where Mr. Spock is born. I'm talking about the planet Vulcan that orbits inside the orbit of Mercury. And because it's so close to the sun, it can only be seen during a solar eclipse. So Mercury has a funny orbit. It's got this thing called a perihelion advance. And the perihelion is the position of the closest solar approach of a planet every time it orbits. And that's usually the same place, but for Mercury it changes. And so you get this series of translocated orbits each time it orbits the sun. And the best minds of the time reasoned that there must be another planet whose gravitational pull is causing this effect. And that was a pretty reasonable idea, because that was how Neptune was discovered. Because Neptune was predicted mathematically as a body, a large body, outside of Uranus's orbit, which caused Uranus's orbital mechanics. But of course, Vulcan was never found because it doesn't exist. And in 1919, Einstein elegantly proved that Mercury's orbit can be predicted perfectly by general relativity. So this is what the eclipse in 1878 looked like, according to drawn diagrams or pictures there. Anyway, let's fast forward to 2017. So this is my expedition. I flew into Denver on Friday night. I picked up my RV Saturday morning, and I got into Glendo in the evening. Because I was flying, I like to fly with carry-on luggage. I had to pack very light, so I just carried this Kenko Sky Memo tracking mount, which I polar aligned the night before. I've got my Olympus EM1 Mark II camera and a 500mm reflex lens. So these reflex lenses are essentially Cassegrain reflecting telescopes. And if you compare one to a refractor type lens of the same focal length, these are both 500mm focal length, you can see that these ones are far more compact and lightweight, perfect for airline travel and perfect for a low capacity tracking mount. Just as a quick aside, a lot of photographers feel that these are inferior by design. But I think everybody in this room will know that any Schmidt-Cassegrain can see just as much as any refractor of the same size. So it's not because of design. Typically, it's because they're poorly made or of inferior quality or cheap. But if you buy one that's well made, it's just as good. So it takes about 3.5 hours to drive north of Denver on Interstate 25 to Glendo, Wyoming. This is the scenery on the way. A lot of highway messaging warning you that it's illegal to stop on the side of the road to watch the eclipse, although I'm sure lots of people did. Reminding people to turn on their headlights during totality. So of course, the night skies are pristine in tiny Glendo, population 200. I think I took this on Saturday night. And a lot of people ask me, how dark does it get during the eclipse? So I took this time-lapse video. I'm not sure if I can get it to run. Oops. Can you click with the mouse? Thank you. Okay, perfect. Yeah, so this is a time-lapse that compresses about 1.5 hours into 2 minutes. You can see the RV park is fairly empty because the owners unfortunately quadrupled the weekend rate during the eclipse, whereas they could have sold out the whole thing if they had maybe had a more reasonable rate. There's my RV. I really enjoyed this RV. It's a Mercedes Sprinter van, which a lot of tradespeople use as their delivery van. Handled very well. It has a diesel, so the economy was almost like a small car. And with a little coaxing, you can get it up to 140 kilometers per hour on the highway. Wyoming has a very liberal speed limit. I tried to convince my wife and son to come with me, but they only wanted to go for 1 day, which is not logistically possible. So I called my old friend who lives in New York City, and he brought his 12-year-old daughter and kept me company. So the idea of the RV was that in case the weather turned sour on Sunday night, I could drive to somewhere like Lincoln, Nebraska, not have to worry about food, not have to worry about finding a motel, and be very mobile as a result. But the weather, as you can see in the sky, was perfect, just pristine for the whole weekend. So we're probably getting close to half an hour from totality here. You'll see me taking the occasional photograph with a white light solar filter. I'm able to control my camera with my Android phone, so that way I don't have to touch the camera at all and disturb its very fine alignment. So we're probably getting close to about 15 minutes out from totality right here. And by this point, you probably can't see it, but the light started turning kind of yellow. You know, colors started to look a little different. No, that's just the time-lapse effect. Yeah, it looks like it's very windy, but because because we're only taking 1 frame per second, it exaggerates the movement of the leaves. That's good observation. And we're almost there. We're going to have my friend's daughter visit us a couple more times, and then totality will occur. Yeah, and there we go. And we're back. Yeah, I didn't look up very much, I must admit. I was too busy concentrating on the camera because I was not going to leave that place without a decent photograph. So I must admit I didn't get the full effect of it. I'll have to save that for Niagara Lake. Okay, so I'll just go back to the next slide here. Yeah, so Glendale was another good place to see the eclipse because totality occurred at lunchtime when the sun's at its zenith, and as Chris was saying, that's when atmospheric seeing is the best way up there and best for imaging or photographing. And this is the picture I took. The camera shoots 18 frames per second, so I could take a lot of frames. I chose exposures, 3 exposures, a quarter second, 1/100th, and 1/400th. Came home, I stacked them, stretched them, did some work with a radial filter, and then made a composite, so you get a sort of like a high dynamic range image of the corona of the sun there. So because of the good weather, about 500,000 people drove in from Colorado to Wyoming, and they decided to all leave at the same time right after totality. So this is the worst traffic jam I've ever been in my life. It took us between 12 and 15 hours to get back to Denver, bumper to bumper the whole way. Yeah, it was pretty bad. And then just before I finish off here, I thought I'd take the opportunity to show you kind of a related picture. This was taken on a Sunday in September. I think it's the first time this may have ever been captured or imaged, because it's kind of a rare event. It's what I call a dual solar and lunar International Space Station transit. So at 8:20 in the morning, while the sun was just rising, I caught the space station flying across the sun. That's this guy right here. And then an hour and a half later, I caught him flying across the setting moon, and that's over here. And I was also very lucky to catch this unknown satellite coming in at the same time too. So I believe this may be the first time it's been overdone. I haven't found anybody else who's ever seen this happen. And we were very lucky that it happened in Toronto, so I didn't have to go very far to actually get it accomplished. And like all good things, like the summer ending, this is the end of my time up here. Thanks very much. Any questions? Yes, very back.
In your time lapse, the camera automatically adjusting the exposure.
Yes, it would
what
be.
I noticed is underneath the awning, it should have gotten pretty dark, I think, to our eyes before it totally cleared.
Yeah, it was set to sort of self-adjust exposure. Yeah, that's correct. Okay, great. Thank you.
Thank you.
So next up, we have Alan Kosugi giving his report on the eclipse. Alan, can you prepare yourself up, please? Put that on there somewhere in your pocket or something. Okay. There we go. Okay. Okay. Sorry.
Got to figure out where my ear is. Okay. Okay. Ah, there. Okay. Okay. I observed from a place in Oregon called Madras, and okay. Okay, and the group I was with, they wanted to start from Vancouver. Being Canadians and some of our party was from Vancouver, and we wanted to get someplace within driving distance of there. So basically we're looking at the West Coast, and I guess, let's see which is the pointer. Okay, whoop, sorry. Okay, Ah, okay. So basically the eclipse went down this way, I believe. Okay. So the choice would have been either go down south down here. This is probably, okay, let me just, okay. So there's Salem, that's where Ralph and his group went, and we decided to go to Madras. It's a little further inland, another mountain range, and you know, eventually we were heading a little further east from here, so it didn't matter to us that we were going a little bit further inland. And as far as being able to reach this, Portland has an international airport, so a short flight, if you were flying, was to go into Vancouver and then into Portland, and then drive probably either this way or along this way and come into Madras. Madras, unfortunately, has only 2 highways in. They are both 2 lanes, 1 lane each direction. Okay, this one takes you through a park, and if you're and further south, you have California. So, knowing that it's a location which is hard to get into and get out of, the idea was that you were committed to getting in there early and probably not leaving the same day. Okay. Yeah. So the idea that we had with Madras is there was a group that had organized a solar festival. They were offering camping accommodations basically from Thursday afternoon till Tuesday morning. And they promised that they would have activities during the weekend. All right. Okay. So this is Mount Jefferson in the back. So we've got the mountain range here. This is Cascade Mountains. And the camping areas were marked off by using weed killer to, a farmer's field was planted with grass, and then they killed the grass to mark off the sites for the camping. Okay, the big brown ones are the expected driving lanes, and the green was supposed to be where you're to camp. And they were officially giving you 20 by 20 feet. Okay, so the idea was that if you were camping and you got only one site, you were expected to put both your vehicle and your tent on that property. And part of this facility is they had porta potties set up. They had okay. Now this is part of an overhead shot. This was captured from a YouTube video on Monday, early in the day. Okay. Whoops, sorry. Okay. So this, in fact, is the local airport. And so that, you know, you had a lot of people that decided to fly in for the airport, for the eclipse on their own private planes. And they also had traffic jams of their own when it came time to leave. Okay. So basically, this is one of the highways that go into town. The town of Madras is about 7,000 people. That's down this way. This group decided that they would have 2 main areas for that they would host. This is out in the farmer's field, which held the bulk of the people. And so, okay, so that's part of the highway. This is looking a little further to the south. Okay. So the airport is out this way. This is the way into town. This is an open area where they gave, they had balloon rides available. They had food trucks around this perimeter. They had some entertainment. They had some, okay, this is in fact the beer tent that they had there. So these are camping areas. Here's a set of porta potties. Here's a set of porta potties. And all of these are different people that have set up in the grid. Okay. Okay. Well, okay. And this is looking towards the west. And at the extreme end, these are the RV parking. They gave RVs twice as much length as they did for the campers. I'm sure they charge you more for it, but they gave them their own separate area. And this is a farmer's field, and this was the early morning irrigation that took place. Okay, well, so basically they threw a big map on the wall, map of the world, and they asked people to put up pins where they were from. And as you can tell, most people came from the West Coast. And my brother comes from up here. So he had to travel a day and a half just to get to here, just to get to Vancouver before, driving in. But, okay. So among the activities that they promised is they held other camping and their events at the county fairgrounds in town. And they had a music festival of sorts, and this is the main stage. They had different lectures. NASA had already committed to having a presence in Madras, so they agreed that they would put on some impromptu lectures. And this was part of, a covered eating area, and at the end of it, they had a stage, and they held talks, roughly one every hour for about 6 hours a day. Not on Monday, but from Friday, Saturday, and Sunday. Okay. Yeah. And this is a shot early on the morning of eclipse day, okay, with some of the clouds. There were high, thin clouds around. Okay. First contact was shortly after 9, so this is just an idea of looking around. If you didn't go down to the open area where the balloon was, you could probably observe from your own campsite. But some people decided that sight lines being what they were, they wanted to be, get a little more altitude. Okay. And this is during totality, and the idea of the 360 sunset. It's a quick handheld shot, and that's why it's kind of blurry, but just to get an idea of what the sky would look like. This is a capture by looking through white field through binoculars on a tripod. And I believe that was done with one of the iPhones in the group. Okay. And this is our group sort of relaxing after totality. And a lot of people tried to leave almost after totality ended. And that's why this particular site is now empty, because they had tried to drive out. Our group had decided that we wouldn't even bother trying to move on Monday. We'd wait till Tuesday. Okay, and this is you've seen the pinhole images. Okay, what we did is we took a fast food tray, a foam fast food tray, and took a pencil and we poked holes in it. Okay, so this was done very quickly, and we decided that we need a good background to demonstrate this. So this is what was chosen. Okay. So before the eclipse at the fairgrounds, NASA had a demonstration. They brought out a white light filtered telescope, and it was surprising to see a lot of people lining up to see different things, hear the lectures, and it was good that you had some place to go in your sort of downtime while you're waiting for things to happen. Okay. This was taken in the evening, and what had happened is these are not just clouds. That's wildfire smoke that had come up during that afternoon from the southwest to the northeast. A big band all the way across, almost 180 degrees, and that's part of the setting sun, or part of the sun coming down at that time. There were lots of different, YouTube video captures. This location, because it was a big campground, it was featured in all of the U.S. network TV coverage. There's a number of things that were captured, but I found that just by searching Madras, Oregon, Solar Town, or Eclipse, you could see all kinds of pictures. I'm not a photographer, so couldn't take any of these exciting dynamic pictures. But our group was very much, wanted to be there and observe. Only one of the group had been to an eclipse before, and certainly he was eagerly preparing his plans to go down to the eclipse for at least 4 years before this year. Okay. Yeah. Okay. Well, and that's it for my presentation. Just an idea that when you get out, this was a different event in terms of you're being out there with a lot of people who were committed to spending time waiting. And what I found is that at times you'd wander around. I did this because I couldn't sleep. I wandered around the field, and you listen to different people talking about different things. And some people were talking astronomy-related things, and other people were, let's say, alternative religious. Okay, well, let's call it that. At times you could pick who you wanted to talk to. You know, if you were sitting down talking to, waiting in line or talking to people that, you had different interesting people that you could talk to or listen to. And that was part of the experience too, is to go out and, look and listen and, and if you have a chance, maybe ask a few people, oh, how you doing? Where you're from? And, a lot of people can tell you interesting stories. And it's not just you getting to one place and then leaving, If you're there, enjoy the experience. Okay, thanks. I guess Tony's up now.
So thank you, Al. So our last eclipse-related roundup talk of the meeting is going to be Tony Hervatten, and I'm the roadie. I'm the guy that sets up the stage for the headliner to come and perform. So I'm going to give you a bit of information, and then I'll pass it on to Tony. So our experience came about because Ian went to OSCI. A couple of years ago, Ian Whaleband and Katrina Inslum went to OSCI, and they met a gentleman, astronomer from Colorado by the name of Greg Halleck. And Greg said, Greg got a ride from Ian and Katrina. I think two are from Sydney, both ways. So they got to know him really well, and he became an honorary Canadian. And by the time they were done that trip, they had managed to get Greg to offer his best friends or one of his good friends vacation properties right on the path of totality of the eclipse. So this fellow wasn't an astronomer, but he owned prime real estate just where we needed it to be. And so a trip was born for about 10 Toronto Centre rascals to head down to Wyoming to see this eclipse. So the way it worked was that Ian Whaleband and Blake Narrow and their plastic mascot, Imperator Pinkarosa, hit the road with Ian's camper, and he took with him Phil Chow, his own, Ian's 20-inch Dobsonian and Phil Chow's 15-inch Dobsonian telescope. And then a couple of us also had smaller scopes and solar scopes and so on, sort of all packed in, jammed into Ian's trailer. And they drove overland, and the Toronto Centre Flyers in the list, Phil and Laura, Grace and Tony, Katrina, Dan, Chris Vaughn, Chris and Sue, flew down to Denver and took rental vehicles to meet them. And where we were rendezvousing was at Merritt Reservoir. So Merritt Reservoir is the location of the Nebraska Star Party. It was supposed to be one of the darkest sites in the continental USA. And we had planned 3 nights of observing at that location. And the first night we got there, it was a tremendous all hell break loose thunderstorm where we feared for our lives driving through it. So that night was out. The following night looked like a good observing night. So we went off away from the campsite, set up our big telescopes, and fought off hordes of hungry mosquitoes because we were the only warm-blooded things, I think, within several hundred miles. And tried to get some observing in, but we kept getting interrupted by vehicles coming in to camp at the campsite. Every 5-10 minutes, there'd be a car with headlights driving by. So it was okay, but it wasn't great. The next morning, dawn broke, and the news started to come up that there were 14-hour or tremendously ridiculous traffic jams in Oregon. And so the idea was sprouted, maybe we better go to Wyoming a day ahead of our plan. So we loaded up the truck and left Nebraska a day early and went to our observing site, which is over here where the stars are in Glendale, Wyoming. So here's the track of the eclipse through Glendale, Wyoming. As you can see, it's 2 minutes and 28 seconds of totality. And this is where our friend Eric Olson had his vacation property. So Glendale population 205, as Jim mentioned, swelled to 250,000 for that day. And most of the people were sort of corralled in the airfield of the town airport and the adjacent state park, where they had set up porta potties and places for people to camp. And we were ensconced in this nice little gated property with about 8 or 10 sort of private homes nestled inside the state park. So we had a much more elbow room where we were. But this is one of the maps that they put up in town near the t-shirt shack, where everybody would put a pin where they're from. And you can see it's Denver. This is Denver. So we're up here. Glendale is somewhere up in here somewhere, yeah. Yeah, down in here. Yeah, right about here. Well, just to give you a sort of a 3D perspective, and the aerial view is going to come back into play in a couple minutes, as Tony will mention. But this is where the place was. It's a lovely large log home with some surrounding property. He had a big boathouse with a nice finished loft, which we all moved into and thought, well, we're just going to call this Toronto House, or Canada House. So, sorry, typo, Canada House. And a lot of us stayed in there. A few people decided to set up tents. None of his property was very horizontal, so tenting wasn't very good, and there was a lot of sharp pine cones and stones and things on the ground. But anyway, we made do. It was wonderful. It was wonderful. We were in a great place. So here's Glendale back here, and here's the area where the 250,000 people were all gathered up here. So we were nice and isolated. So this is a picture of Greg, the honorary Canadian who we met in Australia, or Ian met in Australia with Katrina. And this is our host, Eric, with his family, his father and daughters. And as you can see, we brought some telescopes. So Eric invited about another 80 people to hang out on his property. And so there was about 90 of us. All the comforts of home, running water, showers, beer kegs cooling on the back deck. And so we had a couple of nights of outreach with completely drunk and festive revelers looking through our giant telescopes. I had one guy who was about 6'4", looked like a surfer, looked at Saturn and turned to me and said, "I need a hug." And he gave me the warmest embrace. He was so overwhelmed by seeing Saturn through this nice big telescope. So this is the observing field we had. You can see the big covers on the Dobsonian telescopes, and then some of the solar telescopes are kind of set up here and there as well. Sort of morning of the eclipse. So the morning dawned beautiful, as Jim mentioned. He was just down the road where the 250,000 people were, in that sort of vicinity. We also had a news crew. So we had the Denver 9 news crew here come on to, I guess they knew or heard of this gathering and decided to come and stayed. So they spent the night. Actually spent 2 nights there, and they interviewed Eric in the morning, and Phil got up early, so they interviewed Phil quite extensively in the morning, and so on. So part of what we wanted to do is some outreach while we were there, and these 80 people that were guests of Eric thought that he was so great to arrange to have all these experts on site, so we were happy to do it. So we did the nighttime stargazing, and then we did. I did about a 15 or 20 minute sort of orientation session about half an hour before the first contact, just to explain to people what to do with the glasses, when to put them on, when to take them off, and so on. And also to remind them not to bother the imagers during totality. Because nobody was going to be busy with cameras is going to want to be, answering questions and distracted during that time. Me, not as not an imager, I said that I was, more than happy to have people stand near me, and I would use this app, which was written by or designed by Gordon Telepun, which is the eclipse timer app, which was designed to load all the circumstances of the eclipse and then audibly prompt you to do all the things you needed to do. Look for the horizon, look for the shadow bands, look for the 360-degree sunset and all the various things that happen during an eclipse. So it was great, and we would just shout out commands to tell people to take their glasses off, put them on, and so on. Again, the obligatory colander eclipse. Katrina, the scientist that she is, her sort of pet project during the whole exercise was to take temperature measurements. So this is the data plotted up afterwards. Blake assembled it for her, and you can see that we haven't subtracted sort of the diurnal trend through the day, but it's about a 7-degree Celsius drop. So that was great, another great outcome of the eclipse time. And that you'll notice that there's a lag, there's a delay between the temperature, the minimum temperature. So here's our post-eclipse celebratory picture with all of our eclipse glasses. We took eclipse glasses to hand out to people, but Eric had made arrangements to have some too, so everybody had all the equipment they needed, and it was a great day. We also had about 60 or so people from the neighbors that came sort of in our area. So out of the 150 odd people gathered for the eclipse, only one person had seen the eclipse, had seen a total eclipse before, and that was Charles Darrow. So Charles Darrow and Sarah and their 2 boys were meant to be in Glendo with the throngs, and when they heard about the great digs we had, they decided to do a left turn at Albuquerque and join us. So here's Sarah Seeger and Charles Darrow bringing us up to 12. So I'm going to pass it over now to Tony. Oh, and just once all the revelers went home and we got to do some serious astronomy, we pulled out the ARP Atlas and started looking at some ARP galaxies under this fantastic black, dry desert sky. So it was great. And then Blake and Ian took their road home again. So thanks in advance for pictures included here, Charles and Tony and Katrina and Eric. I put some in, Ian put some in, and Dietmar has done a lot of work for us. I'm sure Tony will mention that as well. So I'll pass it over.
Okay. Well, thank you very much, Chris. That was an excellent intro to our excellent odyssey in Glendo, Wyoming. I have to say right off the top, I really feel extremely fortunate to have been able to participate in that event. And it really is just through the kindness of Eric Olson and of course the connection through Greg Halleck and our own rascals, Ian and Katrina, that got us there. It was just a very fortunate happenstance. I guess before I get into what I want to say about the 2 videos I'm going to show, a couple other tidbits I'll just throw in there before I forget. You may notice we're all wearing these all of us got these very excellent Glendo, Wyoming t-shirts that were put out by the Park Service. And we were very lucky to get those. We just traveled down into the park, was it the morning of or the day before? Day before. And we got them. And so that was really cool. It just seemed to me there was a lot of solidarity and just so much community in the group of us and all the people that were there. It was just such a wonderful event. Just couldn't ask for a more sort of warming 3 days than we were there. So as I mentioned, it was really an ideal location, and you'll see a little bit more of it now in the images that I'm going to show you. So Eric's house was really on the brow of a hill. As Chris mentioned, it was a gated community, perhaps a dozen homes, something of that nature, all spread out. He had about 1.5 acres to himself, but as Chris mentioned, was quite rolling, lots of pine trees, so it was a bit challenging for putting a lot of tents on, but fortunately we secured Canada House, and that worked out very well for us. But it really was ideal to observe the eclipse because what I found, it changed everything for me in terms of how I was going to observe the eclipse because of the western vista. And because we were on the scarp of the hill, we were able to look out way into the distance to the mountains in the west that were way beyond the plateau where we were, and you could see the western horizon. And we knew immediately we would see that shadow from a long way off before it was going to get to us. So most people actually went out onto the roadway of the community and stood on the scarp of the hill to look to the west. So it was kind of like, you know, tripods were here, there, and everywhere, so a few things changed. But I do have to say, you know, all of us really prepared well in advance. We studied, we listened to great talks, Mike Watson's talk, for example, and we thought we were prepared, but I, for one, have to say I was not prepared for this. I was prepared technically and physically and what have you, but I was not prepared for what I was going to see. I'd never seen a total solar eclipse before. As we heard, Charles was the only one there who had. And it was very emotional for me. I think it was, we expected, you know, we were told what you're going to see, but when it actually happens, you're not ready for it. It really is quite an emotional time. And you'll see that in the video. There's some giddiness and some silliness that comes out in the audio track. Well, it's the way it is, and nothing was scripted, you know, it's just the way it turned out. But when you're in a bright and hot, sunny noonday, it was quite windy where we were on the hill. It was just a great hot Wyoming day, and it suddenly turns dark and sunset-like. That's kind of freaky. That was weird. And it was excellent nonetheless, but it was just very, very weird. Now, in our public outreach events at Toronto Centre, we often try to you know, put some scale or some meaning to what the public are looking at and what we're showing them. And one thing I like to do is I like to try to illustrate the scale of things they're looking at. So an observer might be looking at Jupiter, and you'd explain, well, okay, the light that you're seeing that's coming from Jupiter is actually reflected sunlight from the sun. And that light, once it leaves Jupiter, takes about 40 odd minutes to get to your eye. So there is a time delay, even at the speed of light, there's time for that light to get to you. And then I direct their attention to Vega, high overhead. And that light's been traveling for 25 years because Vega's 25 light years from where we are. And then I would say, well, if we gaze to the east now into the constellation of Andromeda, and we look at the galaxy M31, that light left there 2.5 million years ago. And it has been traveling all that time. So when those photons come down through space and strike your retina and send a signal to your brain, that light has been traveling for 2.5 million years. And then you just see the light bulbs going, wow, then they get it. So, you know, you try to look for these kind of eureka moments, but this total solar eclipse blew all of that out of the water. I have to say it. I mean, it just doesn't match. You know, when there's real motion in the heavens and it was just, okay, enough said about all that business. So the first video you're going to see is a streaming of the news item that was produced by the Channel 9 News in Denver. It's about 2.5 minutes or so. And this news item, just a little bit of background on it. Yeah, they were on site for the 2 days or so, but once it was all packaged and edited, they did it all in Eric's house, and then they were going to transmit it over the internet back to the station. Well, do you think they could get bandwidth to do that? No, they struggled. They went to every house in the whole community to try to find enough bandwidth to squeak that transmission out to their station. They'd make the 6 o'clock news, and I believe they did, in about like 15 minutes to spare or something like that, and it actually aired. So what you're seeing here is what they threw up on the air, like with 15 minutes. And it does show a lot of us Toronto rascals doing our thing. And it is used by permission of Tegna Media. The second video, I have to say, I really have to thank Dietmar Kupke. I think he's produced a wonderful collage. It's a 5-minute movie, and it's blending many, many different sources. So we gave him a bunch of things to work with. There are still frames by Ian Wheelband of images on the site, as well as all of the telescopic solar images. There is an all-sky camera view, which Charles Darrow provided. And interestingly enough, you heard about the hot air balloons. Well, there were 2 hot air balloons that were launched in the Glendo area and drifted in front of all of those folks that were down in the airfield. And it happened, and they actually show up in my video that you'll see now. But it so happened that when I was surfing the internet looking for Glendo eclipse video, I found the video that was shot from those balloons. So you can see, and a segment is put in the video as well, you can see what the eclipse looked like at altitude. You can see the sunset around the entire horizon. And you can even get a glimpse of where we were on the ground. If you remember Chris's graphic that he put up, that showed sort of the two fingers of the reservoir to one side and the major tongue of the reservoir to the right were sort of that area in the middle where people's flashes were going off on their smartphones on the ground. So you can actually see that. And I have to put a shout out to Patrick Cloyd, who was the operator, the pilot of that balloon. And thank you very much, Patrick, if you're watching tonight, because we did send you the link anyway. And thank you for letting us use your video in our presentation tonight. And along with all of that too, there is some footage and some stills from an HD action camera that I used. I just set up on the site on a tripod. So some of that stuff is spliced in as well. And one of the things actually I'm very proud of that I didn't really plan much to get from it, but I also set up a dash camera, which I have at that time hadn't been installed in my car yet, but it's an HD dash camera, and it was outfitted with a circular polarizing lens. And I thought, well, it might be interesting to see what happened. And that you will see is the images that show the transition from the partial into total, and then going from total back out to partial. So that's when you see that, it's about 160-degree view with the total solar image. That's the dash camera that's doing that. Now, someone asked me in advance, they thought, well, aren't you worried about letting your camera stare at the sun for like an hour? And I said, well, normally I would, but I thought, this is a dash camera. Don't you drive into the sun? So, you know, we'll see what happens, right? If you kill it, you kill it, but I didn't think it would be a problem. But it all turned out quite fine in the end anyway. And then last but not least, all overlaid on this video was a last minute thought. I simply used my Samsung smartphone and I just did a handheld video. And it's a little shaky, but I don't think we could reproduce what it shows. And you'll see which are the shaky parts. But so I really have to thank Dietmar as a magician, put it all together. And I hope you enjoy it. So just sit back, relax, and I'll ask Andrew then if he doesn't mind. If you wouldn't mind queuing up first, please, the Denver News 9 video, and you can start that at your convenience. And so when we come back, then we'll just take questions, and I guess then we're good. All right. Thanks everybody.
That show in the sky is over, but it's still fresh on people's minds. It's not every day that people cheer and shed tears at the sight of the sun. Of course, today was much different. Thousands came to small town of Glendo, Wyoming to see the total solar eclipse in the path of totality. 90's reporter Noel Brennan and photojournalist Ann Herps were there.
Today's better than we've seen in a while. The day is finally here. So.
A pretty start to a summer day is pretty special when you've been waiting for this day.
And so 47 years.
For about as long as you can remember.
1970, I was like 10 years old. After seeing like a 97% eclipse then, I started looking for a total that I could see, and this was the first one.
Greg Halleck.
Well, there you go.
Focuses on details of the sun.
You can see sunspots.
While his friend Eric Olson scratches the surface.
You should always wear as high as SPF as you possibly can, really.
Years ago, Greg convinced Eric.
I'm the guy, yeah.
To turn his home in Glendo, Wyoming into a campground.
If I can get anything for you, let me know.
On August 21st, 2017.
So that was back in 2014, and I thought, what are you saying?
Now he's learning so much.
So we counted 89 people.
From so many willing to teach.
We're going to see the sun's corona around the sun.
There's a little eruption.
You know, what I'm seeing right now, this very second, left the sun 8 minutes ago.
Among the masses camped out in Eric's front yard.
Guinness Book of Glendo Records or something.
Is a team of astronomers who traveled thousands of kilometers.
I'm from Canada, so we're metric.
To see the solar eclipse at the center of the path of totality.
Yeah, thank you for arranging for the moon to go in front of the sun.
It's my pleasure.
Eric was the gracious host, but Mother Nature was just as accommodating.
Should be about 1 minute before we start seeing stuff.
It's almost like a crescent moon that you'd see in the middle of the night.
The sun's looking pretty much like a banana.
When the star came out, she shined.
Oh, diamond ring. Oh, no glasses. You don't need glasses.
For Greg,
you can see the star next to the moon.
It was worth the travel and worth the wait.
And you can see all the streamers coming off, and that is just gorgeous.
A pretty start to a day. that only got better.
Oh, that was amazing.
Noel Brennan, 9 News.
Amazing the difference of 8% makes. We were at 92%, they were at 100%, and that's insane. So beautiful. Well, good.
I guess they got to add flame because the temperature's dropping. The shadow's coming. The far horizon's getting dark. Oh no. Oh jeepers.
Sunset all around.
Yeah, look at the sunset to the west. Sunset to the west. Oh, look at the sky. Look at up the
Wow. Look at Venus now. Woo!
There it is. Oh, jeepers.
I see Corona. Those fins coming off. The rays. Oh, look at the Corona! Oh, it looks like
Corona.
Look at the plane going above it. Well, it's not above it.
Yeah, the plane going beside it.
Plane going beside it. Looks like it's above it.
Watch your eyes. Diamond ring.
Hoppa! Hoppa! Success! Success. Thank you. It's a great day. Thank you so much, Eric. Enjoyable event for everybody here.
Yes. You can tell you're, you know, pro at eclipse chasing.
Take some questions if you like.
Over here.
How well did you think London was organized? Because I was there on the Wednesday before the eclipse, and it didn't seem to be. We went into the town center and asked them about camping accommodations and what they knew about full versus available spots, and they didn't seem to have a clue compared to Jackson, which had hour-by-hour updates of which places were full, and which places had space, and which were empty. It seemed to be a polar opposite. Glendale the week before wasn't organized, and Jackson was fantastic.
Well, we weren't completely isolated. We weren't dependent on Glendale at all because we had this sort of separate enclave. But Jim might be able to comment.
Yeah, I don't think we were organized at all. In fact, we were routed by the police out of town as quickly as possible. They routed us north for 5 hours. And so it took us 5 hours to get back to Glendale. So they didn't really care about where we were going. They just wanted out of town. So it was very badly organized, unfortunately.
Yeah, because I know when I was there Wednesday, Verizon called and canceled their upgraded internet in town. They had PAL, the cellular unlimited also canceled out on that. It went to Catholic, and they were unhappy about that. But again, I think it was lack of.
Our experience with all the services were really definitely taxed because a town that's normally 200 and you drop whatever's there, there's no way the facilities are going to be handled. The cell service was crushed for the whole day, really. It was, you couldn't get on the system. And as we mentioned about the crew trying to send the stuff back to the newsroom, just by late in the day, they finally got it squeaked out. Anyone else? No? Okay, well, thank you very much for watching, folks.
Thank you. All right, so now a change of pace here. Now we'll have Arushi, Artash, and Vikas Nath talking about their experience with the Canadian Space Apps, and their visit to the Canadian Space Agency. Who's speaking? Are you speaking? You need to put this on. Oh, you're going to use that? Okay. Do you need the mouse? Do you need the pointer? There's the pointer. Leave it to you.
Hi, my name is Artash. Hello, my name is Arushi. A few months ago, we went to the NASA Space Apps, and we each had our individual projects. My project was Drop the Drop, and my project was Yes, I Can. And we are also going to talk about our visit to the Canadian Space Agency. Drop the Drop. So the problem is, climate change is causing more droughts. Droughts are happening for longer duration, and are happening where they have not happened before. The science behind our solution is that healthy vegetation will reflect most of the infrared and absorb more visible light, while vegetation that's unhealthy will reflect most of the visible light and absorb more infrared light. The drought will get triggered when the NDVI is less than 70% of the average value. This is Kenya before the drought. So when it's above 70% of the average. And this is Kenya when the drought happens. So we used our Drop the Drought application on Kenya and Uganda. So we got our base map data. And then we layered it with the settlements and the population density. And then we layered it with the NDVI values from the satellite data. This is a simulation that we've made, gathering 7 months of data into a simulation. So here is Kenya and here is Uganda. So you can see how the vegetation is dying in Kenya. So we could predict the drought from January 2017. We could see it would happen, the drought would happen, and it actually did happen. Because we could see from satellite data for 15 years that from up. Now I'm going to tell you about the Yes I Can project. A few months ago, when we were in the NASA Space Apps Challenge, I heard a Canadian astronaut, Jeremy Hansen, say that if we stop space for 10 minutes, we'll have a big problem. So I thought, what kind of problems will we have? So I went to the reference library and I took a big printout of the RASC image. And then I cut it into lots of pieces. I digitally cut the radar set pieces into pieces, and then I rearranged them to make different shapes and forms. Space makes our phones work. Space makes the GPS work. Space brings together Canada. Space makes us Canadian. Let's celebrate. And now we're going to talk about the visit to the CSA. There's two things that are happening. Visiting the 2 new astronauts and having a tour around the space agency. We took a train to Carbondale. We took a train and we had our Canada arm with us. When we arrived at the John Chapman Space Center, one Canada arm met the other. When we went inside the hall, Jeremy Hansen and his family welcomed us, and we talked to his children. And then the minister welcomed the 2 new astronauts, Joshua and Jenny. Joshua has flown 25 different kinds of aircraft. Jenny mentioned that she liked fire, and that's why she became an astronaut. And then it was time for my presentation. I had lots of questions and I answered them. Then we went on the rovers, where we saw all different types of rovers in the room. Automatic rovers, rovers meant to go to the moon, rovers meant to go to Mars. We met Martin, a senior engineering robotics, and we asked lots of questions to him about the rovers. And then we were actually able to go inside the pit with the lunar rover. And then we went up and we got to the Canadarm section, and Matthew Cameron, supervisor of mission control, explained us all the different versions of Canadarm. And you know, Canadarm was actually not meant to do all this. It was only meant to help assemble the space station. But now it's used for a lot of other things, like capturing other vessels from SpaceX, for example. We met Gilles Leclerc, the director of space exploration, and he told us about the new projects coming. And then we were able to see the control center where the Canadarm is controlled. Actually, we found out that the Canadarm is not directly controlled from the control center of the CSA, but the CSA sends the commands to Houston, and then they communicate to the Canadarm on the ISS. And we met Ed Birchenbaugh, who has trained all of the astronauts, including Chris Hadfield. He knew a lot about the Canadarm and has trained them for a very long time. And he said that third astronauts can use the Canadarm since they can't actually look at it from all different perspectives at the same time. So there's up to 7 cameras on the Canadarm so that astronauts can see where exactly the Canadarm is going, not to bump it against the walls of the ISS. Thanks.
Questions? When did you first get your model of your Canadarm?
We made the model of the Canadarm around a bit before the time of that we went to the space apps. So we had made this Canadarm. It's quite simple. It's just a tube, and we've connected a thing on the top that can grasp objects. So, like, it was meant that people can put their hands inside the tube and pick up objects.
Do you remember what first made you so interested in this science?
Well, there is some time ago, a few years ago. We joined the RASC membership, and we also started with robotics using an Arduino kit. So slowly we started to get more into astronomy and robotics, and we went to all these hackathons like the NASA Space Apps. So yes, we've been participating in the NASA Space Apps for a long time, and yeah.
Well, thank you very much.
Thank you.
So that brings us to the end of the presentations. Normally Ralph is here to do the announcements, but he couldn't make it tonight. But I did want to mention a couple of things just to put it on people's radars. So first of all, our next meeting is going to be, let's see here, the Speakers Night meeting on Wednesday, October 25th. And that's, I guess it's to be determined, that the talk will be determined. This weekend we have the work. Oh, Ralph's giving the talk, that's right. Ralph will be giving that talk on vision in seniors, I guess, or more elderly eyesight. This weekend we have the work party at the CAO. I guess you're fully equipped with help. So there's that one. And I mentioned the various solar observing and dark sky and city observing sessions coming up. So that's good for us until the next meeting. So I'd like to thank everybody for coming tonight and for those watching over the internet. So thanks and good night. And those that want to join us at the meeting after the meeting at the Granite Brew House, we'll head over there and be in the back room. All right, thanks. Good night.